Alright, to build off of what we just learned with direct variation, we're going to talk about slope-intercept form. So instead of y equals kx, okay, we're going to be talking about slope-intercept form, which is y equals mx plus b. Okay, so k is going to take the place of, or m is going to take the place of k, and instead of having, technically there's a plus 0 at the end here, we will actually have a y-intercept. Okay, now if you notice I'm using some words right there that we haven't really talked about before, but basically a y-intercept is where it crosses on the y-axis. Okay, so this is going to be somewhere around here or here or here or here. You know, it could be multiple areas, so it's going to be a dot basically on one of these points right here. Okay, so it just depends on where your y-intercept is supposed to be. Now your slope right here, let's make a different color. Let's go red. I like red. Okay, this is going to be your slope, and this is going to tell you the rise and run. So this is going to be slope, and it's going to equal the rise divided by the run. So if you know your slope, you automatically know your rise over run, and you can actually tell, like let's say that the point was here, the y-intercept was here. I can tell you that I would do the run first, and then the rise second. And I could actually calculate a second point on that function. Okay, so this is rise, and this is run. Now, everyone's done this so far, okay, but how do we actually practice it? So let's go y equals 3x minus 5. Okay, so if we were graphing on a graphing calculator, you just type that in and get it as is. Alright, but let's say we don't have a calculator. So what we would do is first off we would start here at negative 5. 1, 2, 3, 4, 5. Okay, and that would be our y-intercept. So we just leave our dot there. Okay, and then our slope, now if you notice this is just a whole number, but technically slope is rise over run, so this is 3, so it's actually 3 over 1. So that equals my rise divided by my run. So my rise is 3, my run is 1. So let me do this. Okay, my run is 1, so I'm going to go 1 to the right. And then I go 3 up. 1, 2, 3. And so I go to that point. And now this is going to be my second point. And in geometry, we always know that if you have 2 points on a line, that's good enough to draw the rest, if you know at least 2 points. And so that's what the slope is going to look like there. Now, what if I had something else? Y equals negative 1/4 x plus 2. Okay? So let's do coordinate plane. So you draw out your coordinate plane. Pretty simple. Actually, the coordinate plane takes the longest of this problem to actually do it.
And we have another one today.
Okay, so our y-coordinate, our y-intercept would be at 2, so I'd put a dot here at 2. Okay, and then here I would pay attention to slope. So this one's going to be a little bit more interesting. So slope equals negative 1 divided by 4, which means I go down 1, and then I go to the right 4. And you always move the negative up to the top number just because it makes your job a lot easier to tell which direction you're going down. Like for example, up here we had 3, so that was positive, so that's why we went up 3 and over 1. So from this one, we are going to go down 1, so we go down 1, and then to the right 4, which is right over here. And that helps us get our second dot. Okay, and then we can draw the rest of the actual graph. Okay, and so that's how you graph with slope-intercept form. It's nothing too hard. It's nothing too difficult to work with. You might have to actually find, the equation of the actual identifier. I'm sorry. You might have to find the equation given all this information. So you just do the reverse of what I did. You find the y-intercept, that gets you this information first, and then you find the slope by finding 2 points and then calculating the rise over run with it. So you might have to make your triangle a little differently than mine, but remember, if it's going up and to the right, it should be positive. If it's going down and to the right, it should be negative. Okay? All right, now, in slope-intercept, what if I give you a couple of points, so 2, 3, and 5, 4. Okay, how do we find this? What if I had to find the slope-intercept form of that equation that goes through those 2 points? Okay, so first off, you do, number 1, you find slope. Okay, all right, in this case, it's going to be 4 minus 3 on top. And then underneath, it's going to be 5 minus 2. Okay, and that should give us 1/3. So our slope is 1/3. So I now know that this number is 1/3. So I can rewrite this as y equals 1/3 x plus b. Okay, now I don't know b, but here's a cool thing. I do know at least 1x and 1y. So I do know that those are both x and y. So I can actually take that and I can plug that in for this x and y. And if you notice, that's 3 numbers with 1 variable left. I can solve that. So I get 3 equals 1/3 times 2 plus b. Okay, and I just simply solve it. So this becomes 3 equals 2/3 plus b. And then I minus 2/3 from each side, and I should get 2 and 1/3, or 2.333, or 7/3. It all depends on how you set it up, and that equals b. Now, whichever one you get, you would just plug it right back into here. Okay, and then you would just plug it back in with the 1/3, and so your equation for this line would be y equals 1/3 x plus 7/3. Okay. All right, so you could get it that way. Should have wrote 7/2. Plug in m, x, and y into y equals mx plus b, and solve for b. Okay, and once you do that, you can actually just go to step number 3, which is plug in m and b into y equals mx plus b. Okay, and once you have those two, you should be able to set up and be able to figure out this part right here. Okay? So the line that contains these 2 points is just 1/3 x plus 7/3. Okay? And once you got that, it's really easy to come up with any kind of line in the future. Okay? All right, so some simple stuff to work with. All right, thank you very much. Have a great day.